Okay, hello. Let's go ahead and go over this. I'm coming to you from last year. Ooh, I recorded this before break. So let's warm up with this check for understanding. The Pew Research Center randomly selected 100 mothers aged 40 to 44 in 1976, 1994, and 2014. 100 people, and we have a two-way table. So we've got 300 people total, 100 from each year. So suppose we randomly select one of the survey respondents and define events C as having 4 or more children. So this is event C. And we have S as and N and F are the various years. So I'm just going to put S, F, and N. Find the probability that C given S. So this is a conditional probability. So I'm going to write this out. So given S, what's the chance of C? Okay, that's kind of how to read that. So given that we've got somebody from 1976, so that's what I'm interested in. So the second number that's always your bottom number in your fraction. That's how you can think about it. It's a little trick. So we're kind of going to write this like this. The probability of C given S. I always think of it as like, all right, I got to find C out of the S's. There's my fraction. So we've got 100 people in the year in event S in the year 1976. And I'm specifically looking for event C where I have 4 or more children. So that's going to be this part. So I've got 40 out of 100. So if I interpret this value, this is going to be essentially in many, many women, if I pick many, many, many mothers in this age group, in the long run, the chance of me getting somebody from 1976 that has 4 or more kids is 40 out of 100, or you could say 40%. Okay, problem 2. Given that a chosen mother was not surveyed in 1976, what is the probability that she has 4 or more children? So let's write this in probability notation first. So we're not surveying in 1976. That's what's given to us. So we know we have somebody not in 76. So the complement of event S. So not that. And then what is the chance she's got 4 or more kids, which they defined as event C. So again, we want to look for this number, not S. I'm going to switch colors. So that's going to be these 2 columns. So I'm looking at a total of, so not S, and I want to find C out of that. So this part, don't write on your AP exam. This is just me showing you a trick. Don't put that part, but put this part though. And then this is 200 people were not in 1976 because they could come from 94 or 2014. So then out of those, I've got 2 options here. I got to combine these options, 13 and 13. So there's 26 out of 200 for that. So what we want to look at is, are the events surveyed in 76 and 4 or more children independent? So what I want to think about is I have my event, 4 or more children, with a condition with being in 76 and not being in 76. So I have it, and I have it with the condition and without it. And I'm looking at 4 kids in either spot. And so there's a 40% chance here. And then here, 26 out of 200, I can convert that to a decimal, or I kind of know that's not 40%, but you could see that that's not 40%. So we would say no, not independent, because when I change the condition for having 4 or more kids, the likelihood of me getting a family with a mother with 4 or more kids changes. So if the probability changes when I change the condition, that means that condition on there is affecting my results. So no, not independent. The probability of C given this does not equal probability of C given we are in 76. So you can put this in probability notation, or you can describe it in words if you want instead. So either way is fine. So this is reviewing a little bit of independence.